Zuzana Hromcová. Please welcome her. Thank you, everybody.
Okay, hi everyone. Thanks for coming. So I'm Zuzana. I work for ESET, and I'm not sure. Oh, okay. You already see the slides. So I work in ESET as a malware analyst, and today I'd like to talk about an espionage platform that we discovered. We named it ATTOR. But just before I start, I want to ask you a question. How many of you remember AT commands? Please raise your hand. Okay, some of you remember. So for those of you who know, you will know that these commands were created in the 80s and they were used subsequently. And maybe you will not be so surprised to learn that I'm too young to remember these commands. I wasn't even born in the 80s. So when I first seen these strings in some malware sample, I didn't really know what was going on. It didn't really ring a bell. But of course, I have some older colleagues who did recognize these commands. And even they were wondering, what are these commands doing in some malware sample? This is not something you are seeing every day, right? So we started to look into it, and we started to analyze this malware. And then we realized that the fact that something is old doesn't necessarily mean it cannot be used today. Or in this case, surprise, misused. So let's meet ATTOR. So just to start, when we started looking into the ATTOR malware, we were able to trace it back to 2013. So it has been undercover for quite some time now. We have analyzed several different versions, but the most important one was released in 2018 when the developers of ATTOR released some new improvements, some more structured architecture, and really just more professional code. And this version is the one that is still used nowadays. We detected last samples in July this year. So this is the one we are going to talk about today because it caught our attention with its functionality and complexity. And this is what we are going to talk about. So this talk will be first about the espionage campaign itself. We are going to look into what ATTOR is spying on and who it's spying on. And then, of course, we'll talk about how it's implemented because that's interesting about it. And then we will talk about two notable features that gave ATTOR its name, and that's the elaborate network communication using Tor, and then the AT commands used for GSM fingerprinting. So let's start with the targets. The first thing we knew about ATTOR is that it's highly targeted. We only had some 20-something targets detected. And among these targets, there were some high-profile users in Eastern Europe. But of course, this is only our telemetry. We are likely only seeing some part of the picture. So that's why we had to look further, and we wanted to know more about other targets that we do not see. So we analyzed the code of this malware, and we were actually able to learn something more about the intended targets of ATTOR. So I'm going to talk something about how the platform looks like so that you can understand how we were going with this discovery. So first thing you need to know is that this platform consists of a dispatcher, both 32 and 64-bit version, and then it comes with a series of plugins with some additional functionality. So how this platform comes to life is that first the dispatcher is injected into all running processes, and subsequently it loads all the plugins into these processes. And the thing about ATTOR is that each of these individual plugins then decides in which of the processes it will be activated. So for example, the plugins that are responsible for network communication are only activated in applications that already communicate over the internet. This is a clear attempt to hide the malicious communication within a regular stream or network traffic. So similarly, for example, the plugin responsible for audio recording is activated in applications like Skype or some VoIP applications. Again, these applications are likely already using the microphone. So this is also same for other plugins. What we are concerned about here is the plugin that is responsible for taking screenshots of individual applications in which it is activated, and then to be able to report on victims' activities. So this screen grabbing plugin is, again, not activated in all of the processes, just some applications of interest. And we are going to look further into it. You just need to know that this plugin contains a list of some strings, which are then being looked for in process names and Windows titles. And if these strings are found, then this plugin is activated and is taking screenshots of these apps. So first, when you look at the list of these apps, no surprise here. What you'd expect, some social networks, email services, and maybe some office apps. But when you look further, you can find strings like приглашение дружить or Yandex Pošta. And all of these strings are actually associated with some applications that are used in Russia. And they include the two most popular Russian social networks or a VoIP app that is provided by a Russian telecom operator. So our conclusion here is that Attor is specifically searching for users that are Russian-speaking. And this conclusion is further supported by our telemetry. Indeed, most of the targets were located in Russia. So further about the targets, we're looking at the strings in the same plugin. And we discovered it was interested in some other applications like digital signature creation applications or VPN applications, secure email, or TrueCrypt. So it seems like Attor is also concerned about privacy-concerned users. And actually, when we looked further in the code, we see some other traces of Attor being interested in TrueCrypt. So this is a part of the code where Attor is trying to detect a TrueCrypt driver on the compromised computer, and then send some control codes to the driver. And when you look at these control codes, these are not standard codes. They are TrueCrypt specific. So, and these are used to recover the actual version of TrueCrypt installed on the computer. And this case say two things. First of all, indeed, it seems like Attor is interested in privacy-concerned users. On the other hand, we can see something about the skills of the authors of this malware, because this is not a very usual technique. It's actually pretty rare. So just to recap, we have seen the ATTOR'S is pretty highly targeted. It has some targets in Eastern Europe, which are high-profile users. Also, it targets individual Russian-speaking privacy-concerned users. We have also seen that Attor is using quite some interesting tricks to do this spying, and this is actually what the next part of the presentation will be about. We are going to talk about how this platform is implemented, how it works, and what's interesting about it. So as I already mentioned, the core of the Attor platform is the dispatcher, which is a DLL. First loaded, and then it works with the other plugins. But there are also some other notable features and parts of the platform. The inter-process communication between all these components is done via some shared local folders, meaning that some of the components write files to these folders, other reads from them, and this is how they can all communicate. So these are the 4 folders that were used by the plugins. And then now for the plugins, there is an installer plugin that takes care of the persistence of the whole platform. And there is a set of some, say, espionage plugins that collect sensitive information and store this information in the upload folder. And now you could imagine that all this information should be ultimately exfiltrated to a remote server, but none of these plugins actually communicate with this server directly. They're all offline. So there is another infrastructure for talking to the server. As you can see, it's a Tor service, so it cannot be done directly. So what happens here is that a file uploader plugin monitors the upload folder, and if there's some new information, some new data, it then prepares the data for exfiltration. And to be able to reach out to the remote server, it uses 2 other plugins. This is just a simplified graphics, but basically it uses a Tor client to be able to resolve the onion domain, and of course to choose the circuit, encrypt the data, and then relay the communication. So this is one part of how Attor communicates with the CNC server, but of course there is the other part of the communication where the server wants to reach back to the platform and to the compromised computer and maybe send some additional instructions or tools that are to be deployed on the machine. So again, it uses the same infrastructure with Tor, but the data is then relayed to yet another plugin, which we called Command Dispatcher. And then this plugin can interpret the instructions, and if there are any new files or updates, then these files get stored in the shared folders. And how it works then is that the dispatcher then can monitor these folders, and if there is some new plugin, then this plugin will get loaded so that you can always have your malware platform up to date. So this is how it works. I would just like to point out that none of these plugins on the left communicate with the internet directly. They just use these shared folders so that they can communicate with the actual plugins that are responsible for the network communication. So if we just concentrate on these plugins, we can see the communication is split into 4 components. Each of them is implementing a different layer. And these components communicate with each other. These two create local servers that the other components can then connect to. And only some of them are communicating with the control server directly using FTP protocol in passive mode. I already mentioned that these plugins are only activated in applications that already communicate with the internet, which is one of the tricks that ATTOR uses. Another trick is, of course, that it uses Onion Service Protocol for its CNC server, aiming for anonymity and untraceability. So this is how network communication works in ATTOR. Now let's look closer at how the individual plugins are implemented. So when you look at some of the plugins of ATTOR, you can see that it's not so easy to analyze them without having some further context, because there are a lot of calls to some mysterious function that you don't know anything about. But if you have access to all of the ATTOR components, you can actually see that this function is implemented in the dispatcher, so the main part of the platform. And it serves like as a proxy for Windows API functions, for cryptographic functions, etc. So instead of calling these functions directly, the plugins will call the function of the dispatcher and then use some indices to tell the dispatcher which function should be used. And then the dispatcher can then translate the function to some meaningful code. And only if you have access to all of these components, you're able to tell what these plugins are actually doing. So an important thing here is that remember that all these plugins are injected into the same process as the dispatcher itself, which means that they share the same address space, and that's why it's possible to call these functions like that to reference each other's functions. And the reference to this function is passed to the plugins on load by the dispatcher. And this is how it looks like. When you look at the plugins, it's also DLLs, nothing special at the first sight. They use these export names that are pretty common. But when you look at this export, DLL get class object. This is the most important one. So what it does here, as I said, the dispatcher passes a pointer to the most important function, and then the plugin stores the reference to this function in a global variable. And another thing which happens here is that the plugin then returns its plugin ID and the actual version back to the dispatcher. So the dispatcher can keep track of all the plugins that are loaded, and if there is some update, it can decide whether this is a newer version or not. So this is how it looks like. All the plugins have this kind of exported function. So it was the same for all the plugins that we analyzed. And these are all the plugins that we are able to collect, to recover. You can see all the IDs and versions. And maybe an interesting thing here is that the IDs seem to be continuous. And you can see that we probably don't have all the versions. And it's not surprising at all, because this ATTOR campaign is highly targeted. So probably the attackers use different sets of plugins per victim. So we didn't see all the victims, so of course we don't have all the plugins. And another thing is that it's pretty complicated to collect these plugins because they are DLLs, but they are encrypted on disk. asymmetrically. And if you don't have access to the dispatcher, which has the decryption key, you cannot really recover the plugins. So they're only fully recovered in memory if you also have the dispatcher. So this is just another complication that the developers of ATTOR created for us. So these are all the plugins that we recovered. And we're not going to talk about the keylogger and the screen grabber and plugins like that, because I think you've seen quite a lot of these. But let's just focus on this one plugin that we call Device Monitor for some reasons. For example, it has plugin ID number 1, and this is a prominent spot, right? So maybe this is some plugin of importance for the ATTOR platform. And again, it has a version number 14, which means that there were quite a few versions of this plugin. It's the highest number that we have seen among all the versions. So maybe it means that the developers behind ATTOR put some effort into developing this plugin, so why not look closer? And the most important reason why we are going to look into this Device Monitor plugin is that it's responsible for the most important functionality that we have seen in ATTOR, the GSM fingerprinting. So let's look closer. You have already seen this slide, these strings. Now let's put some meaning to these strings. So as some of you know, these correspond to commands from so-called Hayes command set or AT commands, and they were created in the 1980s to communicate with modems or some older phones and to be able to change connection settings or to dial up. But later, there were other commands added. The set was extended both by some proprietary commands and some standardized. So there are quite a few AT commands now. And what these actually mean, these are the commands that the ATTOR was using. So this command is used when you want to start a communication with a device that is connected to the computer, add for attention. And if you want to use the extended commands as well, then you use this command. And the other commands are used for querying some data from the device, such as the model number or the device manufacturer or the software version. And then there are more important or more interesting commands. For example, this one, which is requesting the IMEI EI number from the device. This is a unique identifier of the device. Further, it requests IMSI number, which can identify the device subscriber, or it's the owner of the SIM card that is put into the device. And also, it's asking for the MSI SDN number. This is a number which is responsible for mapping between the identity of the owner and the telephone number. So this is the kind of information that ATTOR is after. Let's just quickly recap. What ATTOR does is that when it detects a device connected to the computer, it starts sending AT commands. And then via these AT commands, it is able to learn information about both the device and the subscriber of the device, so the owner of the SIM card. Now, you may have noticed that I mentioned the word device quite a few times, but I never said what I mean when I say device. And this is actually a question that we were asking. What kind of devices is ATTOR looking for? Is it some old modems? Because first, the AT commands were used for communication with modems, so maybe this is the case. Or is it some older phones? These also have support for AT commands and SIM cards, so maybe this is what ATTOR is after. But then we're thinking maybe it's also some more modern devices which also use SIM cards, such as smart cameras, smart watches, or even modern smartphones. So is it possible that AT commands are still supported by these devices? And is it possible that this is what ATTOR is after? So we were looking, and we found this paper, which was published last year, and gave us some answers. So actually, the AT commands are still supported on modern smartphones. There are thousands of these commands supported, different for different manufacturers and firmware. But more importantly and more disturbingly, it still poses a security risk. If you are connecting your device via an USB interface to the computer and then sending AT commands, you are able to change the device firmware, inject touch events, or query some interesting data from the device. So actually, this paper showed us that it's still possible to communicate with the modern smartphones just via the AT commands. So we were really interested in whether this is what ATTOR'S after. So we look at the code, and this is a code for checking whether ATTOR should be sending the AT commands to the connected devices. And we can see that it checks the friendly name of the device, and it should have COM substring in the name. Well, if you connect a smartphone to your computer, usually you use a USB port, and what you see in the name is some strings like USB, VIT, or maybe the name of the smartphone. So unless you are connecting your smartphone via some serial cable or some USB to COM adapter or some special setup, probably this is not what usually happens. So COM is probably just after some device is connected to the serial port or virtual serial port. So it seems like maybe this is not the main focus of the ATTOR'S authors, maybe just in some special configurations. So we had to think of some more explanations, and we actually considered the totally opposite explanation. Maybe this code is just some residuum from some older versions. We have seen that this platform has been around since 2013, maybe even older. So maybe if you look at the code, it only targets the serial port. And you can remember that the modems and some older phones support AT commands. So maybe it's just all that it's about. But then when we look at our telemetry, we learned that actually this plugin is still included in the newest version that was released in 2018, and we never seen an old version of this plugin. And also, we have seen a 64-bit version of this plugin detected in this year. So to us, it seems like the developers of ATTOR know what they're doing. It doesn't seem like they're just releasing 64-bit versions of some old plugin. So we had to look in some more explanations. And another hypothesis is that there is actually a device that can be both connected to a serial port or a virtual serial port and can answer to AT commands. Maybe it's some device that the victim's organization or the victim itself is using. Maybe we don't know about this kind of devices, but we can assume that the actors behind ATTOR could learn about these devices via some other techniques of reconnaissance. We don't know, but what we can tell is that if this is true, then this is just the beginning. Because there are further AT commands that we haven't seen used in ATTOR. As you can remember, the commands that were used were only used for querying some basic information such as device ID, manufacturer, subscriber ID, and stuff like that. So it seems like some fingerprinting of these connected devices. But when you look at all the other commands that are supported in all the different devices, there are thousands of vendor-specific AT commands. And if the actors behind ATTOR learn about what kind of device is connected to the computer of the victim, then they can create other customized plugins and push them back to the victim's computer. We have seen that there are mechanisms in place so that these plugins can be then loaded and used. And this can be actually used as a base for further data theft. So this was about the GSM fingerprinting. Now let's wrap it all up. We were just talking about an espionage platform that we called ATTOR. We have seen that this malware is targeting both high-profile targets in Eastern Europe and privacy-concerned individual Russian-speaking users. Now, we don't know who is behind ATTOR, but what we can say is that it was professionally written, it had some unusual functionality, and there must have been invested substantial resources into developing this kind of malware. Another thing, as usual with APTs, we don't have all the pieces of the puzzle, so we don't know everything. But what we can tell from what we see is that ATTOR malware is worth further tracking, and it could be interesting to collect the other remaining plugins and to see what else it has as its tricks. So this was for my presentation today. I would like to know that this was a last-minute talk, so if you're interested in more details, there won't be a paper in the conference proceedings, but we are going to publish a comprehensive white paper with more details, so stay tuned. And that's it. Thanks for your attention. If you have any questions, I will be happy to answer them.